Introduction to tornado formation. Tornadoes are powerful and destructive atmospheric phenomena characterized by their rotating columns of air extending from a thunderstorm to the ground. Understanding what causes tornadoes and how they form involves exploring the interplay of atmospheric conditions, wind patterns, and storm dynamics. Tornadoes can cause severe damage, making it crucial to understand their formation and behavior. Atmospheric conditions and tornado formation. Tornadoes typically form in severe thunderstorms, particularly those known as supercells. These thunderstorms have a well-defined rotating updraft called a mesocyclone, which is crucial for tornado development. The primary atmospheric conditions required for tornado formation include instability, wind shear, and moisture. Instability and thunderstorms. Instability in the atmosphere occurs when warm, moist air near the surface rises and meets cooler, drier air aloft. This creates an unstable environment that can lead to the development of thunderstorms. In a supercell thunderstorm, the rising warm air is forced to rotate due to the presence of strong wind shear, which is the change in wind speed and direction with height. Wind shear and rotation. Wind shear plays a critical role in tornado formation by causing horizontal rotation in the atmosphere. When winds at different altitudes blow at different speeds or directions, they create a rotating effect. This horizontal rotation can be tilted into a vertical orientation by strong updrafts within a supercell thunderstorm, forming a rotating column of air known as a mesocyclone. Formation of the tornado. Once a mesocyclone develops, it may extend downward to form a tornado. The tornado forms when the rotation within the mesocyclone tightens and intensifies, drawing in more air and increasing the rotation speed. The lowering of the mesocyclone can produce a visible condensation funnel, which extends from the base of the thunderstorm to the ground, resulting in a tornado. Tornado structure and dynamics. A tornado typically consists of a narrow, rotating column of air with a low pressure center. The strongest part of the tornado is near the base, where the rotation is most intense. Tornadoes can vary in size, from a few dozen meters to over a kilometer in diameter. Their wind speeds can range from weak, EF0 level tornadoes to violent, EF5 level tornadoes, with winds exceeding 200 miles per hour. Tornado life cycle. Tornadoes have a life cycle that includes 4 main stages: the developing stage, mature stage, shrinking stage, and decaying stage. During the developing stage, the tornado begins to form and intensify. In the mature stage, it reaches its maximum strength and size. The shrinking stage occurs as the tornado begins to weaken and narrow. Finally, in the decaying stage, the tornado dissipates and loses its intensity. Tornadoes and geography. Tornadoes can occur in many regions but are most common in areas where the necessary atmospheric conditions align. In the United States, for example, tornadoes are most frequent in the Tornado Alley, a region stretching from Texas to Nebraska. However, tornadoes can occur in other parts of the world, including Europe, Australia, and South America, though they are generally less frequent. Tornado safety and preparedness. Due to their destructive potential, understanding tornado formation is crucial for safety and preparedness. Tornadoes can cause significant damage to buildings, infrastructure, and landscapes. It is important to have a plan in place, stay informed through weather alerts, and take appropriate safety measures, such as seeking shelter in a basement or interior room during a tornado warning. Conclusion. Tornadoes form from severe thunderstorms, particularly supercells, through a combination of atmospheric instability, wind shear, and moisture. The interaction of these factors creates rotating columns of air, leading to tornado development. Understanding the conditions and processes involved in tornado formation is essential for improving safety and mitigating the impact of these powerful natural phenomena.